Today we are going to look at section 6.4, which is vectors and dot products. This can be found on pages 429 to 433 in your textbook. So let's look first at this other vector operation. So last section we looked at two vector operations, scalar multiplication and addition. The dot product is yet another vector operation. So if we look at the dot product, you take the dot product of two different vectors, so u and v. Essentially, the dot product, you take the first component of each vector multiplied together and add it to the second component of each vector multiplied together. Now, when you do that, the answer that you end up with is going to be a scalar or just a number, as opposed to being another vector, like we saw when we were doing scalar multiplication and addition. Okay, so let's do a couple examples. So we're going to find the dot product of each. I'm going to go through all the steps for these few. So we are going to start with taking 6 times 1, so first part times first part, plus 2 times 3. We'll multiply and then add them together. 6 times 1 is 6, 2 times 3 is also 6, and 6 plus 6 is 12. So notice my final answer is just a number, a scalar, not another vector. Let's do the next one. So 2 times 1 plus 2 times negative 1. I get 2 plus negative 2, which is equal to 0. And the last one is just giving us a different representation of our vectors. So we're going to do u dot v for the dot product. And my vector u is I plus 4j, so it's written right now as the sum of a unit vector, and I can change that. So coefficient with I is 1, coefficient with j is 4, so the vector u would be the same as 1, 4, and v would be the same as 3, negative 2. So now we're actually taking the dot product then of 1, 4, dot 3, negative 2, and that gives me 1 times 3 plus 4 times negative 2, which is 3 plus negative 8, which gives me an answer then of negative 5. Okay, so just be aware of those different ways they can represent the vectors. Let's do a few more, this time adding in some other operations that we did in the last section. So when I look at number 4 here, I'm going to start with what's in my parentheses. So I'm going to start with this dot product. I will get a scalar answer that I'm then going to multiply by this vector w. So let's do u dot v first. So that's going to be 3, 4 dot negative 2, 6. So I'm going to get 3 times negative 2 plus 4 times 6, which gives me negative 6 plus 24, which is 18. So now I'm going to take that 18, I'm replacing it where the u dot v is, and I'm substituting in vector w. So now I'm going to end up essentially doing scalar multiplication. So I have a scalar now that's being multiplied by another vector. The scalar distributes to both parts, leaving me with a vector answer of 18, negative 18. So depending on what operation you finish with influences like what your final answer is. So since I ended up with a scalar multiplied by a vector, I ended up with a vector answer. Now let's look at our next one. So for this one, we should actually perform the scalar multiplication first prior to doing the dot product. So that means I'm going to start with this 2 times this vector w to get 2, negative 2, and now I'm going to do my dot product. So I'm going to take my vector u, 3, 4, dot this new vector of 2, negative 2, and I'm going to perform the dot product. So 3 times 2 plus 4 times negative 2 gives me 6 plus -8, which gives me a scalar answer then of -2. So since I did the dot product last as my last operation, I get a scalar answer, okay? And number 6 is actually a review of something that we did in the last section. If you remember, this notation is simply saying find the magnitude of u. I'm reviewing this for what we're going to do next. So the magnitude of u, if the vector u is 3, 4, the magnitude is found by taking the square root of 3 squared plus 4 squared, which is 9 plus 16, and that's the square root of 25, which is just 5. And again, your answers for magnitude is also just going to be a scalar or a number, because magnitude is representing the length of the vector. Okay, so moving on, the other thing that we're going to look at is the angle formed between two vectors. So if you have two vectors lined up at initial points, we can use this formula to help us find the angle formed in between the two vectors. So this formula is cosine of theta. Theta is going to be your angle, equals u dot v, so this is what the dot product is useful for, divided by the magnitude of each of these vectors. So keeping in mind that theta, this angle, can be measured in either radians or degrees, so just making sure that you have your calculator in the correct mode based on what the question is asking. So let's look at an example here. So we're going to find the angle in radians between these two vectors here, u and v. So let me just write the formula. So cosine theta, u dot v over the magnitude of u times the magnitude of v. So I'm going to find all these pieces first, and then we'll substitute in. So let's start with u dot v. So dot product u dot v, 3 times 1 plus 0 times 6 gives me 3 plus 0. So the dot product of u dot v is 3. Let's find the magnitude of u and v then. So magnitude of u would be the square root of 3 squared plus 0 squared, which is the square root of 9 plus 0, which is just the square root of 9, which is 3. And the magnitude of v, square root of 1 squared plus 6 squared, which is the square root of 1 plus 36, which is the square root of 37, and I'm just going to leave it as that for now. Okay, so now that I calculated all these pieces, let's go ahead and substitute in. So cosine of theta is 3, that was my dot product, over 3 times the square root of 37. So if I simplify that, I get that the cosine of theta is 1 over the square root of 37. And 1 over the square root of 37, I'm okay if you leave it like that. That's not your final answer. So it's okay to leave it like that for now. This is not found on the unit circle, so we are going to have to use our calculator to calculate this. So in order to find this angle theta that I want, I'm going to have to use the inverse cosine, because that's how we find angles. So second, or the shift button on your calculator, cosine to get the inverse. So inverse cosine of 1 over the square root of 37. And this is where it's important to make sure for this example that your calculator is in radians. We're going to round to the nearest hundredth, and I get 1.41 radians. And that would be the angle formed between these two angles. Same process for if you were finding the angle measure in degrees, you would just change the mode on your calculator and type in the same exact thing. I did go ahead and calculate that for you so you could visualize this a little bit better. This would be the same as 80.54 degrees. So just depending on what the question is asking, make sure you have your calculator in the correct mode. I wanted to show you what this looks like so you can also kind of visualize it better. So here's your picture, here's your vector u and your vector v. You found this angle formed in between them. So that angle would be 1.41 radians or 80.54 degrees, which is about what it looks like there. Okay, so just be aware what mode you need to be in when you're calculating this. And to wrap up then, we are going to look at the definition of orthogonal vectors. Now this word orthogonal is the same as perpendicular. So how do we find or how do we determine if vectors are perpendicular to each other or if they form a 90-degree angle? So if you think about that vector definition that we just went over, and you think about cosine of theta, like where at cosine of 90 degrees, well, cosine of 90 degrees is 0. So two vectors are perpendicular if and only if their dot product is equal to 0, giving that numerator of 0, creating cosine of theta equaling 0, meaning that theta would be 90 then. So the way that you can check whether vectors are orthogonal or whether they are perpendicular is to take the dot product of the vectors and see if it's equal to 0. So just another quick example to wrap up here. We are going to determine if these are orthogonal by taking the dot product. So negative 1230 dot 5/4 1/2. That would be negative 12 times 5/4 plus 30 times 1/2. Negative 12 times 5/4 is negative 15. And 30 times 1/2 is 15. Negative 15 plus 15 is 0. Since I got a dot product of 0, yes, these vectors are orthogonal, or yes, they are perpendicular to each other. And that is it for section 6.4.